I lost you?
I don't know how.
All right. Okay, so we're going to be, this whole chapter is talking about radicals. But this begins real easy. So what I'm going to show you first of all is we're going to look at if you did square root of 4 times square root of 9, would that be the same thing as the square root of 4 times 9, where the 4 and 9 are outside a radical versus where they're inside. It's very easy to show that this works, okay? So let's do this. Square root of 4 would be 2. Square root of 9 would be 3, so 2 times 3 would be 6. Agreed? Okay. Well, if you do this, okay, this would be square root of 36, right? So if you did the 4 times 9, what's the square root of 36? 6 also, so it works. And it turns out that it works for all radicals. So if you did this problem with cube roots, tell me what the cube root of 8 is. 2. How about the cube root of 27? 3. So that would also be 6. Okay. Well, if you took like your calculator, and if you did like 8 times 27, let's see, that would give 216. So this part right here, if you bring that down, would be cube root of 216. You know what that is? It's 6 also. So that's the way that works. Now, one thing I do also want you guys to write down, because I see this all the time in higher math, even with calculus students, if you had like 4 plus 9, like that, okay, a lot of times students think that you could do this, but you can't. If it's addition, you cannot just go through and do that like this, okay? A better example would be to show this, like, let's write this down. Square root of 16, let's see, plus, oh, let's see, hold on, 9. This is the example I always give students, okay? If you did this, you would get square root of 25, which would give you 5, right? You would do the 16 plus 9, kind of like an order of operations. But I want you to notice, if you did the square root of 16 and the square root of 9 separate, you would get 4 plus 3 is 7, so it doesn't work. So what's important is, it works when you multiply, but it doesn't work when you add. And it doesn't work when you subtract either. So we're just looking at what we call the product rule for radicals, okay? So the first thing we're going to start with is like super duper easy, okay? There ain't going to be much you do on this. So this one, you're multiplying two like radicals. They're both square roots. So according to this property, all you have to do is put it in one radical and multiply it together. Now those radicals both have to be the same. You can't mix a square root and a cube root. So the answer is square root of 10. Problem done. That's all there is to it. You're just learning the fact that you can multiply radicals together. Okay? Okay, second problem, we do the same thing. They're both square roots. So you just write one square root. Then you do x over 5 times y over 7. Okay, if you do that, you're going to have x times y is xy. 5 times 7 is 35. So you just write the answer as xy over 35 like that. Nothing to it, right? That's super easy. Now the next problem you can do two ways. Okay, first way I'm going to do, and it doesn't matter which way you do, except one way is a little easier than the other. So if I did 27 times 125, I'm going to do it this way first of all with my calculator. So if you did this, you would end up with the cube root of 3,375. Right? Okay. Now what you'd have to do is get your calculator out, because this is a pretty big number. If you're going to do a cube root on a TI, what you do is math. Then you can go down to option 4. If you have a scientific calculator, you probably should have a cube root somewhere. So if I do the cube root of 375, that's going to give 15. Now, I wouldn't do the problem that way. I'm going to show you the way I do it. Okay? Although it's not wrong to do it that way, you just pretty well need your calculator. You can also do it this way, because you can do this in your head. Tell me what the cube root of 27 is. 3. How about the cube root of 125?
5.
It's 3 times 5. That's the way I do it. It's like that. Okay? And what I recognize is I recognize that I knew those two things. So if you know that radical and know that radical, you're just as well to go ahead and do that and do it that way instead of the first way. But either way, it'll work. It's kind of up to you. Okay? Okay, so if I look at this one, start the same way. We're going to do 180 times 5. I'm pretty sure if you do that on a calculator, that's probably 900 is what that is. Okay? So you can do the square root of 900. So the way I do this is, what's the square root of 9? 3. So the answer is not 3, it's what? 30. Okay, because 30 times 30, if you work 30 times 30 out, you're going to get 900. You can use a calculator if you have to, though. Okay, so that would be the way to do that problem, is like that. Now, the reason I wouldn't do it the way I did number 4, where I just did the radical of both, see, if I do like the square root of 180 on my calculator up here, I got a bunch of decimals. So you don't want to go there, and if you did like the square root of 5, same thing would happen. So my suggestion when you look at these problems is, if these things are decimals, then just do it that way. Okay? If you know the answer, like you do on number 4, like you knew the cube root of 27, cube root of 125, then don't multiply them out. That would be my suggestion. Okay? Okay, next problem. Let's do this. Same idea. Put it under the same radical. You're going to do 7x to the third times 7x to the fifth. Okay? So what is 7x to the third times 7x to the fifth in your head? 49x to the eighth. Good. Okay, remember you're adding the exponents. Okay? Now, let's see if we remember this. What's the square root of 49? 7. How about the square root of x to the eighth? X to the fourth. Okay, remember when you do a square root, you're doing half the exponent. A square root is the same thing as half the exponent. So all you do is just take that 8 and you take half of it, so you get 4. So the answer is 7x to the fourth, like that. Okay, that's how you do a square root of any power. So real quick, what would be the square root of x to the 200th in your head? X to the 100th, right? Okay. Half the exponent, half the exponent. That's how you do the square root, okay? Okay, let me do this next one here. Okay, now let's see if we, let's go ahead and just multiply this out first of all. So if we did this, what I'm going to do is you could take your calculator and you could take 8 times 125, using your calculator to do that. That would give 1,000, okay? And then what is m to the third times m to the third? M to the 6, correct? Okay. So if you did this problem, now if you needed to use your calculator, you could. If you needed to do the cube root of 1,000, you could certainly do that on your calculator if you wanted to, but you shouldn't really have to. What is the cube root of 1,000 anyway, you think? 10. Why? Because 10 times 10 times 10 is 1,000. So that would give 10. Now let's see if we remember this. We may have already forgotten this, but this is stuff we did in 7-1. What is the third root of m to the 6th? M to the 2nd. And see what happens is, that's really 6 over 3, right? Like we were doing today. What's 6 over 3? 2. You just take that and divide it by that, so you would have m to the 2nd like that. That's the answer. Okay? So you can do the problem that way if you want to, or you could do it this way. This is something we also learned in 7-1. What would be the cube root of 8m to the third? 2m, right? How about the cube root of 125m to the third in your head? 5m, right? What's 2m times 5m? And same thing. Okay, do it either way. Okay, that's the way I do it too, is because if you observe that you can do the radical, it's easier to do it that way. Okay, so I'll let you guys do these problems. It's the same way. You can just multiply them together and simplify if you can. And you can use your calculator if the numbers are pretty big, if you want to. Then we're going to do the same thing with the quotient rule. And then this is, to me, is the simpler part of the section. Then we'll spend the rest of the time on the simplification here. Okay, so here's how I'm going to do number 8. Okay, so if you multiply together, you'd have square root of 9, right? So what's the answer to this problem? 3. That's the easiest way to do it, like that. Okay, all right. Now another way to look at this is 3 times 3 is 3 to the 2nd, right? Okay, if you want just to kind of show you how these properties work, that's really 3 to the 2 over 2, right? Isn't that 3 to the first? You can do it that way too if you want to. Okay. Okay, the next one, let's see how many people did it this way. Now, I think a lot of you probably did it this way. I probably wouldn't do it this way. But if you did 16 times 625, I think you get 10,000, don't you? So you would have the fourth root of 10,000, okay? What number would you multiply out 4 times that would give a 1 with 4 zeros by? 10, okay? You can do that on your calculator. So you should have got 10. The other way to have done this problem would be, what number do you multiply out 4 times that gives 16? 2. What number do you multiply out 4 times that gives 625? Did anybody do it that way? Okay, that's the way I do it. But either way is acceptable. Okay. Okay, the next one, you're pretty well forced to go through and just take your calculator and do 32 times 50. See, the square root of 32 is decimals, so you don't want to go there. So if you put that together, you'd have 1600. Now, I would hope that you wouldn't have to fumble for your calculator to figure that out. What's the square root of 16? 4, but the answer to this problem is what? 40, right. Okay, so you can use your calculator if you have to. That's it. Nothing to it. Okay, then the next one, if you put it in one radical, you'd have 3 times 3 is 9. X to the third times x to the fifth would be x to the eighth, right? So what's the answer? 3. Square root of 9 is 3. Half the exponent on that is x to the fourth. That's it. Okay, problem done. Okay, that's how you do the product rule for radicals. Does that make sense to everybody? Okay, that's not too hard. This is not the hard part of the section. Okay, next thing we're going to do is the quotient rule, which is very similar. Multiplication and division work the same way. So if you were doing the square root of 9/16, well, the answer would be 3/4, right? And the reason for that is because if you did 3/4 times 3/4, you get 9/16. Agreed? Okay, we've done square roots of fractions before. You've learned how to do that. So would it work if you just did the numerator and denominator separately? What do you think? Square root of 9 is 3, square root of 16 is 4. Exactly. So if you've got a square root of an entire fraction, or any root of an entire fraction, really all you got to do is just do the numerator and denominator separately. It always works. So what would be the answer to this problem? Cube root of 8 is what? 2. Cube root of 27 is what? 3. Okay, the reason that's the answer is because if you took 2/3 and multiplied it out 3 times, what would that give you? 8 over 27. So it checks. Yes.
So if you just did 9 divided by 16 and square root that, that's easy.
You could, but if you did 9 divided by 16, you'd get a bunch of decimals. And you'd have to do that probably with a calculator. So it's much better to just do top and bottom separately. That's the idea. Although your method would work if you did 9/16, got a decimal and did the square root, it'd still give you 3/4. Your calculator would probably give you 0.75 because that's what 3/4 is. Okay. Okay, so let's do some of these. These are all pretty easy to do. So when you do problem 13, I think I'm not quite ready to do the whole thing on this problem yet. Let's actually change this problem, okay? Because we're not ready to do anything with 48, although we're getting close. Let's change this to like 25 over 49, just something like that. Okay, so if we do that, you can do this problem in your head. What would be the answer to the problem? 5 over 7. Okay, just doing top and bottom separate. Okay, and you're going to do all these problems basically the same way. So number 14, just do the square root of the numerator and square root of the denominator separately. Okay, so do you know the square root of 4? What is it? 2. Do you know the square root of 11 off the top of your head? I don't either. But you know the square root of 9. What's that? How about the square root of 16? Does it make sense that the square root of 11 would be somewhere between 3 and 4? Yeah, so if you went through, and you don't need to do this, but if you did the square root of 11, you'll just get a bunch of decimals, 3 point something. I don't want you to do that. What I want you to do is just simply leave that alone. Okay, so we're not going to do anything. If the radical doesn't turn out to be a whole number, we're not going to do anything with that, at least yet. Okay, so just leave it alone. Okay, next problem is going to go like this. We're going to do square root of 9 x to the second y over square root of 49. So again, you just break it up into 2 parts, and then you do what you know. Okay, so what's the square root of 49? 7. What's the square root of 9? 3. What's the square root of x squared? How come?
You're having
half the exponent. Half of 2 is 1. Okay, or x times x is x squared. Okay, so that's going to come out. But then you're left with this thing, square root of y. Okay, now that's a second root and that's a first root. What you're going to find is you can't do anything with this problem because that number is less than that number. All we know right now is how to do a square root of an even exponent. We don't know how to do anything else yet. So if that was square root of y to the 10th, then what would it be? Y to the 5th, okay? But since that's an odd number, we're not ready to do anything with that. So what you're going to do is you're just going to leave that alone like that. You could write y to the 1/2 also. It's not necessary to do that, but it's not incorrect. Okay, the point that I want to make right now is all we know how to do is the square root of something to an even exponent. That's it. We're going to learn how to deal with the odd in a little bit here. Okay, so this problem right here, what you want to do on this is you want to do this backwards. I have two radicals, right? Well, I can put it in one radical, just kind of backwards of what I was just showing you. So let's just write one radical, and let's do 125 over 5 like that. Okay, you can do that. That's the property. Now, if you want to take your calculator, if you need to, you could take 125 divided by 5. You know what that is? It's 25. So what's the answer to this problem? 5. The square root of 25 is 5. So what I'm showing you is you can do this backwards. If you have two radicals to begin with in a fraction, just do one radical. Simplify, then do the square root. That's what I'm going to do on the next one as well. Okay? So if I do this one, they're both cube roots. Now they both have to be the same radical. You couldn't have a third root and a fourth root because then you can't do it this way. So this one you could do cube root of 15 over 5, right? Okay, well, what's 15 over 5? We'd have cube root of 3. Now, that's not one of the ones you know a cube root of. If you needed to, as you're kind of learning this, if you did the cube root of 3, you're going to get a bunch of decimals on it. That's not what I want. So the problem's done. That's it. Okay, if that doesn't simplify, if you don't know what that cube root is, then you're done. Okay, so that's the idea. Okay, these are all fairly simple to do. Let's kind of get these done, and then we'll get into the good stuff. Okay, so go ahead and work these out. And just to kind of start you off on the first one, that's what you do. You have a radical of a fraction, do top and bottom separately. If you know a square root, do it. If you don't know the square root, leave it alone. Okay? Same thing on 19, and then 20 and 21, you're doing that backwards. You're putting that in one big radical. Okay, so that's the difference between the approach and the two problems. Now, I think number 20, you can get the answer in two different ways if you do that. If you get into some pretty big numbers and need to use a calculator, you can certainly do that. Right track of these. These are pretty simple to do. What did you get for your answer on 18?
Square root of 3.
That's it. Square root of 3 you can't do. Square root of 3 is decimals. Leave it alone. So don't do anything there, but the square root of 64 is 8. That's all I want you to do. How about 19? What's your answer? 9 over 7. You know the square root of 81. You know the square root of 49. Okay? Now this one you could actually do one of two ways. Now the first approach is to do 1296 and then divide that by 324, which is probably 4 is what I have a suspicion of. Okay? So I square root of 4, so what's the answer to this problem? Did anybody do it a different way?
No.
What did you do?
You could break it down and do the square root of 1296 and the square root of 324.
Okay. Okay, you could also do this, I think. You could go square root of 1296 with your calculator, because I have no idea what that is, so that's 36. Okay, and then you could also do the square root of 324. So if you do square root of 324, that would give you 18. So what's 36 over 18? Anybody do it that way? You could. Okay, works either way. Okay, next one's going to go like this. If you do, if you put it in one radical, then if you do 162 divided by 2 should be 81. What is x to the 11th over x to the 1st? x to the 10th, because you subtract exponents, right? Like we're doing today. So you would have 81x to the 10th. So what is the answer? Good. Square root of 81 is 9. When you're doing a square root of x to the 10th, you're doing 10 over 2. You're doing half of that. So that's x to the 5th like that. 9x to the 5th. That's the simplest way to do that. There are other ways, but that's probably the simplest way. Okay? Okay, now the rest of the section gets into how you simplify radicals. So, and we can look at this in a couple of different ways. First of all, one of the things that you want to do is, let me give you an example of a square root and just kind of show you the idea. Okay, so remember, one of the things is, like if you had the square root of x to the 8th, you need to know automatically that's x to the 4th, right? Because that's half the exponent. But if you had, let's write this down, like the square root of x to the 9th. We haven't learned how to do that yet. Well, what you do is you break it up into factors, and you want it to have an even exponent. So you actually break it up like this, x to the 8th times the square root of x to the 1st. Because after all, it's the same thing. X to the 8th times x to the 1st is x to the 9th, right? So you break it up like that, then what do you know? What is the square root of x to the 8th? X to the 4th. And then you just have a square root of x like that. That's how you always break up square roots, is like that. So just one more real quick. It's real simple if you know what to do. If you had the square root of x to the 101th power, how would you break it up? Square root of x to the 100th, like that. That's how you got to break it up. Because it's the same thing. Now, what is the square root of x to the 100th? It's not x to the 10th. I see students do that all the time. What do you do with the exponent? Half. So it's x to the 50th times square root of x. So that's how you're going to deal with square roots, is you want to break them up into an even exponent and whatever's left over. That's the idea. That's how you simplify when you have a square root. Now, if you get that down, all the other roots are the same thing. So let's look at a cube root. Let's say that you had, just as an example, let's say we had the cube root of x to the 12th. Can you tell me what that is? What is it? It's really the same thing as x to the 12 over 3, right? Like we learned today. What is that? X to the 4th. So that's x to the 4th. See, all you're doing is really, when you're doing this, you're just dividing that into that. 3 goes into 12 4 times. Problem done. But if you had something like this, if you had the cube root of x to the 14th, well, here's what you would do. See, 3 does not go into 14 evenly. It goes in, and then there's something left over. There's a remainder. So what you would do is you would break it up into the cube root of x to the 12th times the cube root of x to the 2nd. So what's so special about 12? Well, 3 goes into 12, right? So what you're going to do is you're going to make the powers be multiples of 3. So what you want to do is you want that thing to be divisible by 3. And one way to do this is to count by 3s until you get close to 14. You can go 3, 6, 9, 12. Then you get to 15, so it's too big. So you want to go with 12 like that. Now when you do this, that would be something we know. We know the cube root of x to the 12th is x to the 4th. Then we have this leftover x to the 2nd like this. And you can't do anything with this because that number is less than that number. Okay, does that make any sense? If it doesn't yet, it's going to, because we're going to focus the rest of the class doing a lot of this stuff. Okay, if you have a 4th root, okay, let me give you an example. What if you had the 4th root of x to the 20th? Do you know what the answer to that is? You need to fast immediately. 20 over 4 is 5, right? That is the same thing as, like we learned today, that's x to the 5th, okay? So let's say that you were doing the 4th root of x to the 23rd power, okay? Does 4 go into 23 evenly? No, that means you have to break it up. So you count by 4s. You go 4, 8, 12, 16, 20, then 24 is too big. That's bigger than 23. So you would break it up into the 4th root of x to the 20th, and then what's left over? X to the 3rd. Right, okay? And then this would be 20 divided by 4 is 5, so that'd be x to the 5th times 4th root of x to the 3rd. So what you're doing is you always want to make sure when you break up a fourth root, what's the deal with that number there? It's got to be a multiple of 20. That 4 has to divide into that, and all roots are the same. They're all the same. The concept's exactly the same. Okay, a couple of things that are helpful in doing this section is to have as many of these things memorized as you can. These are just perfect squares, okay? Memorize them up to at least 144, okay? When you have cube roots, memorize it at least up to 125. Okay, we've already talked about that. Fourth roots, usually maybe the first three or something like that. You don't have to have them memorized, but it is helpful if you do because you can do your work a little faster. Okay, so what I'm going to show you how to do is two ways to do these problems. Two ways. Take your pick. I like to show two ways because some students like one way better than the other. First thing I'm going to do is we're going to do on this problem, we're going to do like a factor tree. I'm going to teach you that way first. Then I'm going to teach you the way that you can do this in your head, that's your goal when the numbers are small. Okay, if we do a factor tree, what are two numbers that multiply to give 50? Well, you got two choices. You could do 5 and 10. You could do 25 and 2. Okay, 5 is prime. It doesn't go any further. But 10 is 2 times 5. So back to kind of doing a factor tree. So what we're going to do is, let's do it this way first of all. We're going to write this as, notice that we just had 1, 2. So I'm going to write that for emphasis as 2 to the first. Then I have 2 5s, right? So that's going to be 5 to the second like this. Now if you learn to do it this way, then you don't have to have any of those numbers memorized. Okay, this is a nice way to do the problem. Okay, now, do you know what the square root of 5 to the second is? It's 5, right? Okay, because again, you just divide those exponents. That's 5 to the 2 over 2, so that's 5 to the first. So this thing right here just comes out of the radical. That just becomes 5 to the first, and then what's left over is that 2. And the reason I know that that's left over is because that exponent is smaller than that, right? That's real key in these problems, is whatever you're left with under the radical, that exponent better be less than that. If it isn't, you haven't done it correctly. So the answer to the problem would just be 5 times the square root of 2. Okay, like that. That's how you would simplify that radical. Now that's one way to do it, is with a factor tree, and what you're doing is you're looking for even exponents. Okay, when you're dealing with the square root, you want the exponents to be even. Okay, now if you don't like doing it this way, some students don't like doing it this way, some students like doing it this way, you can also do it this way. Okay, if you look at your list of square roots, let's see which one of these numbers goes into 50. Does 4 go into 50? No. Does 9 go into 50? No. Does 16 go into 50? No. Does 25 go into 50? Yes. Aha. So we could just write this as 25 times 2, right? Okay, then what's the square root of 25? 5, and then you're left over with the radical 2. Isn't that easier? A little bit? It's a little less work. And that's the way I recommend that you do these problems when the numbers are small. If they're big, then you probably need to do that factor tree way. But you can always do the factor tree way if that's what you like, because it's always the same thing. Okay? So the answer would be 5 radical 2. Now you can do this, like you can check your answer on a calculator with this. So if I did the square root of 50, I'm going to get decimals. I don't want decimals unless I specify that. That's 7.1 approximately. If you take our answer and do 5 times the square root of 2, you should get exactly the same thing, and we do. So you can tell you're right. You can tell that you've done that correctly with your calculator. The other way that you can check, and this is worth writing, so as we get to our third test, I always have you check your answer on this for an extra half of a point. Well, what do? You just take your answer and you square it, okay? Because that's how you check a square root, is you take your answer and multiply it by itself twice. So if you did this, look what would happen. You would have 5 radical 2 times 5 radical 2. If you do that, 5 times 5 is 25. Square root of 2 times square root of 2 is 4. Square root of 4. Square root of 4 is going to be 2. 25 times 2 is 50. You're back to the beginning. Okay, you can do that. So you can take on a square root. You can multiply your answer by itself, and you can tell it's right. Does that make any sense? That's an awfully nice thing to know how to do. And when you do your homework, you need to check some of these, because that's how you will learn and remember and understand this. Okay, don't be lazy about that. Check it out. Okay. Okay, next one, square root of 35. If you did square root of 35 on your calculator, you're going to get a bunch of decimals. Again, that's not what I want. So I don't want the decimal answer, but the answer is 5.9 and then a bunch of decimals forever. Okay. If you did a factor tree on this one, it would be a pretty boring factor tree. It'd be 5 times 7, right? That's it. So what you would write is you would just break this up into 5 to the first times 7 to the first. Now the reason I'm doing it that way is I want to emphasize something. Okay, what did I say about when you're simplified, how does this exponent have to relate to that name of the radical? Less than, right? That's already less, that's already less. So guess what? We're simplified already. Now if that was a 5 to the second, well then we could do something with that, okay? If that was 2 or bigger, we can still simplify.
Why would it not be under the whole entire thing? Why should it be 2 separate roots?
Why did I do what?
If there's a 23, 24, why did you separate them? Across the first one?
Well, that's a part of what you're doing when you're simplifying a radical. Is ultimately what you're doing is you're looking for a number that goes into 50 that's a perfect square. That's why I chose 25 times 2.
Right.
Or if you look factor tree way, you're looking for at least 2 of something. Okay? Because those things match up. So like if you were doing a square root of a bigger number, like you'd be looking for some even exponent and whatever's left over in your factor tree. Or if you do it this way, you're looking for a number you know a square root of. So you wouldn't break it up into 5 and 10 because you don't know the square root of 5 and you don't know the square root of 10. You do know the square root of 25. That's why you break them up. That's how you got to simplify these things, is by breaking them up, and one of the radicals got to be something you know. Okay, this one's already simplified, so you're done. Okay, the other way to look at this is like this. Okay, if you look at these perfect squares, does 4 go into 35? No. Does 9 go into 35? No. 16, 25, in fact, none of those numbers go into 35, so that means you can't do anything with the problem. Okay, that's the idea. Okay, let's move to the next one here. Now we're going to do a cube root. Now I'm going to do factor trees a lot, and then I'm going to show you the other way. Okay, let's do a factor tree on this one. Now the cube root of 384 is decimals. If you do it on your calculator, you'll get decimals. So what I'm going to do is I'm going to do a factor tree. The first thing I know is it's an even number, so I'm going to divide that by 2. So I'm going to have 2 times 192. Every time you have a prime number, circle it. Okay, then I'm going to do 192. I'm going to divide that by 2 again. So that's going to be 2 and 96. Okay, when I get to 96, I can divide that by 2. I can kind of start doing this in my head now. So that is 2 and 48, like this. Now you can keep doing 2 if you want to, or you can do something like this. If you want to do 6 times 8, you could do it that way. Okay, well 6 breaks down into 2 times 3. So we have that. 8 breaks up into 2 times 4. And see, every time I got a prime number, I circle it. That's how I keep track of what I have. Then I got 4 is 2 times 2. Does that look okay? We've done factor trees before. Okay, you can do it this way if you want to. I recommend you learn it this way because the numbers, you're not always going to see what number you should use to break this up. Let's count how many 2's we have. 1, 2, 3, 4, 5, 6, 7. So let's go ahead and write this problem as cube root of 2 to the 7th times, and then we have 3 to the first left over like that. Okay? So if you can do your factor tree, then you can get everything broke up. All right? Is everybody with me so far? Okay, now, does 3 go into 7 evenly? There would be a remainder, right? But what you can do there is, you want this thing to divide into that. So go by 3's. 3, 6, 9. You could break that up into 2 to the 6th times 2 to the 1st. Why would you do that? Because 3 would go into 6, right? That's what you want. You want it to be a division problem that goes in as a whole number. Look at the 3. Is there anything you can do at the 3? How do you know that's simplified? That number right there is less than that number. That's what I said. So if that number is less than that number, then there's not a thing you can do. So what we're going to do is we're going to break it up like this. The 2 to the 7th we break up into 2 to the 6th times 2 to the 1st. The 3 to the 1st we leave alone. Okay, like that. Okay? Why am I doing that? What is 6 divided by 3? 2. So this part of the problem right there would just be 2 to the 2nd, right? That would come out of the radical. Okay? And then these things would be trapped and they would stay there forever and ever and ever. So here's what you do. You can take this one out of the radical. The cube root of 2 to the 6th is 2 to the 3rd. Or no, 2 to the 2nd. 6 over 3 is 2. Okay, now you can write it this way if you have to, but you're going to do this in your head anyway. That comes out of the radical. Then you'd have left with a cube root of 2 times 3. So you would have 2 to the 2nd. Then you could multiply the 2 and 3 back to get a cube root of 6. So you'd have 4 times the cube root of 6 would be your answer to your problem. Okay? And students usually it takes it. Just hang on. Students every time I teach this, it always takes a while to get students' brains wrapped around this. But it's not that hard. Just listen very carefully. All in the world you're doing on a cube root is you want to break this up so that number 3 goes into that number there. Okay? 3 doesn't go into 7. It's got a remainder, right? Now, if you want to, you can do the problem this way. You could just do 7 divided by 3. That goes in 2 times. And there's what? A remainder of 1. There's your remainder right there. That's what's left over. Whatever goes there would be what that power is. Everybody agree that 2 to the 6th times 2 to the 1st is 2 to the 7th?
Yes.
Why did I use 6? Why? Because 3 goes into 6 evenly. That's why. That's all you're doing. And these things are left over because their exponents are smaller than 3. Once you get the hang of it, there's nothing to it. Okay? But the first thing is get that factor tree done. Okay? So I'm going to do that one with a factor tree. I'm going to do the same thing with this next one to get you started.
Still confused about the 4.
With the what?
Where did the 4 in the answer come from?
Okay, right here.
That's how many 2's there are?
Right there.
I can't see where you're...
Okay, 6 over 3. See, we're doing 3 goes into 6 twice. 2 to the 2nd's 4. Okay? When you do this right here, 6 divided by 3 is 2. So that thing becomes 2 to the 2nd. 2 to the 2nd's 4. See, work it out. Okay? All right, let's do the next one the same way. Okay, now this time we're looking for 4 of something. How come? Because it's a 4th root. Okay, you want to make sure that when you do your factor tree that you have at least 4 of something. Okay, do the factor tree. So let's start this one by doing 2 and 81. Okay, 2's prime. 81, you could do 9 times 9 if you want to. Okay, 9 is 3 times 3. And then that second 9 is 3 times 3. Okay, so we're going to write this as the 4th root of 162. Okay, what do you have in this factor tree? What do you have? 2 to the 1st, and then what? 3 to the 4th, okay? Everybody with me on that factor tree? Okay, you'll get it. Once you get it, you'll wonder why it's so why it's difficult, and it isn't. Trust me. Okay, is that okay? The 4th root of 2 to the 1st, is that done? Yes, how come? That's under them, okay? How about this part? What's the answer to that part? Just divide. 4 divided by 4 is 1, so it's 3, right? That comes out of the radical, okay? So what you're going to have then is you want that 4 to go into something evenly. So what you're going to have is when you do the 4th root of 3 to the 4th, what do? You just divide those exponents. So you do 4 over 4, that's 3 to the 1st, right? That comes out of the radical, right? Because you know what the 4th root of 3 to the 4th is. Okay, so that's out. It's 3 to the 1st. What's left underneath? 2. There's your answer. That's it. Okay, so what you're always doing is you're always looking for breaking those exponents up in a certain way. And you're kind of putting everything together now when you're doing this now. Okay, that's how the numbers work. Exponents all going to work the same way. So let's do this next one. Okay, so we don't have to do a factor tree on this. This is variable. So if it's a square root, what kind of exponents do you want? You want something that divides by 2, right? What numbers divide by 2? Even numbers. Okay, so when you're doing this, we already looked at this a little bit earlier. Just do count by 2s, 2, 4, 6. What is the closest even number that's less than 5? 4. So you're going to break this up like this. You're going to break this up into the square root of y to the 4th times the square root of y to the 1st. Okay, like that. Right? Now, what is the square root of y to the 4th? That's what some of you don't seem to see. That's y to the 2nd. What are you doing? 4 divided by 2 is 2. That's the reason you do this is you want a division problem that comes out to be a whole number. So that's y to the 2nd. How about this thing? Anything you can do with that? No? How come? That exponent's less than that. So you'd end up with y squared times square root of y. That's your answer to your problem. Like that. Okay? Seriously, there's nothing to it. It's all division. Okay? If you want to do it this way, you can do it this way. You can do 5 divided by 2. This is a second root. That goes in 2 times with 1 left over. The significance of that remainder is that thing right there. That's what's left under the radical. You can always do it that way if you want to. Okay, same idea. Okay, let's see if we can figure this one out now. Okay, if it's a cube root, we want that 3 to go into that exponent. Does 3 go into 14 evenly? Yes or no? No. So what you can do is just kind of count by 3s. 3, 6, 9, 12, 15. What's the closest one to 14 that's less than 14? 12. So you break this up like this. You say cube root of p to the 12th, right? And tell me what would be left over. P to the 2nd. Okay, right? Does that make sense why I'm doing that? Same idea. 12 divided by 3 is 4. It's a nice whole number. Now all we got to do is finish the problem. So what's the cube root of p to the 12th? P to the 4th. Okay? Same question. Why is this done? That's less than that. Okay? You can't do anything with that. That's too small. Okay? So the answer would be p to the 4th times the cube root of p to the 2nd. Okay? If you want to do division on these problems, you're always welcome to do that. Because see, what this is, when you're doing the cube root of p to the 14th, you know what you're really doing? You're doing p to the 14 over 3 like I taught you earlier today. If you do 14 divided by 3, look what happens. You're going to have how many left over? 2. The significance of that 2 is that thing right there. Okay, where's the 12 come from? 3 times 4 is 12. You can always do it that way. If that's what you catch on to best, do it that way. Okay? Okay, let's do one with a couple more to finish up here with a 3rd root and then maybe a 5th root. Okay, now here's what you look at on this. The cube root of x to the 4th is that 4 is bigger than 3, right? So that means you got to break it up. That 5 is bigger than 3, you got to break it up. Now, do you know what the cube root of 27 is? What is it? 3. So go ahead and do it. Okay, so if you know that number, then go ahead and do it. So what I'm going to do is I'm going to have you break it up into one radical. Now, if you know 27, you can leave it there. You could also do a factor tree if you didn't know that. That would be 3 times 9. It would really be 3 to the 3rd. Okay, and the significance of that is, that's what we want, is we want these exponents to be something 3 goes into. So let's we can either leave it as 27 or you could break it up and write that as 3 to the 3rd. I'm going to go ahead and do that. Okay, how do you think you would break up the x to the 4th on a cube root? 2 things, x to what power and what left over? X to the 3rd, x to the 1st. Good. Okay, why x to the 3rd? Because 3 goes into 3. Why x to the 1st? Because that's what's left over. Okay, tell me how you'd break up the y to the 5th. Y to the 3rd and what? Y to the 2nd, good. Okay, so we got y to the 3rd, y to the 2nd. All right, now what I'm going to do is all of these things right here that I'm highlighting, those things come out of the radical. How come? Because 3 goes into 3, right? So they are going to come out. So when you do the cube root of 3 to the third, what is that? That's 3 to the first. It's out of the radical, right? What's the cube root of x to the third? X to the first. What's the cube root of y to the third? Y to the first. Okay, tell me what's left over under the radical. Whatever had smaller exponents than 3. So it'd be x to the first, y to the second. So what you do is you'd write the answer just as 3xy times the cube root of x to the first, y to the second. Okay, now I think I'll show you how to check this one, and then I'll finish up with this last problem here. Is it making better sense? Slowly? It's not that hard. Okay, I'm serious. It's just getting your numbers to break up, split up, so you have a nice division problem. That's it. Okay? All right, let me show you how you could check your answer on this then. And this is important because I'll let you do this on the next test. Whatever your answer is, what you can do, and the best way to check this answer is to just take this thing and raise it to the third power. Why? Because you're doing a third root. You want to see if you multiplied this thing out, you're hoping that the result of this problem is what's under the radical. Now watch carefully how I do this, because you want to catch on how to do this pretty quickly. Okay? Now this is a first power, a first power, and a first power. You're going to multiply these exponents. So that's going to be 3 to the 1 times 3. That's going to be x to the 1 times 3, just like we did earlier today. That's going to be y to the 1 times 3. You can do that in your head. Now go under the radical and do the same thing. 1 times 3, x to the third. 1 times 3. 2 times 3, do like that. Okay, now watch how this works out. This is important. Okay, it's not that hard to do. This would be 3 to the third. This would now be x to the third, y to the third, and it would be cube root of x to the third, y to the sixth. Okay, let's work it out. 3 to the third's 27, and we'd have x to the third, y to the third. Tell me what the cube root of x to the third is. Well, man, you need to be fast on that. 3 divided by 3 is 1. What's the cube root of y to the sixth? Y to what? Second. 6 divided by 3 is 2. Now, if you multiply this together, notice, what's x to the third times x? Isn't that x to the fourth? Okay, what's y to the third times y to the second? Ah, it matches. We're right. You need to know how to do that. That's the only way you really understand what you're doing when you simplify radicals, is how to check it. That's where the deep understanding goes, and that's what you want to focus on. Okay? You'll get